So what we're going to go through now is just how to use the command line tool and the GUI that you just might have seen popped up on the screen, different ways of processing images using that tool, dealing with ROIs, labels, and we're going to get a bit into the mechanics of how it works so that you can write your own commands and do your own image processing pipelines. So by way of introduction, C3D is a command line tool for image manipulation, and it's a companion to SNAP, so it can do a lot of the same things as segmentation and dealing with labels. It's also a pretty good standalone image calculator and an interface to a lot of ITK filters for many standard image processing tasks. It will handle floating point images much better natively. You don't have to load them as integers. You can do math, smoothing, and other stuff. And because it's a command line tool, it can be automated for processing multiple images. So it can be run from the GUI or from the shell. So if you're on a Linux or Mac system or you have a shell environment, you can script it to automate stuff. We're going to do everything in this session in the provided GUI. So we'll go through that just right now. So here it is. There's three main kind of areas. There's one place where you put your commands. There's a box for output, and then there's a file navigation area on the right that you can use to move around your computer and find images you want to work on. So we'll just quickly go and look at it. Okay, so here we are. We start off with C3D. We can bring images in from the left here, from the right here by double-clicking. We can also tab to autocomplete. So do that. And you'll see an image that exists is a link. You can double-click on it and actually open it in SNAP. Okay, and then we can do some commands. Let's do commands start with a minus sign. Again, we can tab to autocomplete. If we don't remember, we can say we want some information about this image. And then when we're ready, we hit execute. And the output appears down here. This is information about that image we just loaded. And then at the bottom it says it ran successfully. And if it didn't, it'll tell you in red letters why not. Okay, so to start over, we just hit clear. And we're back to the beginning. And if we want to change directory, we can move around. Just using these tools, you can see the directory is here. Okay, and there's a history here if you want to go back and
file browser too, right?
Do some stuff. Okay, so back. So some basic image math we can do. We're just taking in two images. Addition, we can add, multiply, divide. There's a ton of functions. They're pretty well documented on the C3D website. If you just want to see the names of things, you can do C3D-H for help, or you can tab autocomplete if you know basically what you're looking for. So how is a command structured? Starts off with C3D. That's actually optional in the GUI, but we always start with that just to be consistent with how it runs on the command line. Then you give it images with file names, and then commands begin with a minus sign or a dash. So commands can be followed by parameters, such as here there's a minus type short, which tells it to change the data type it's going to deal with to short, which is a kind of integer. These are read left to right, so the position of these matters. So if you used Unix before, you might see these minus flags and think they go anywhere like they do in most commands, but actually this is a kind of mathematical expression that's read left to right, so the position matters. So in the example on the bottom here, if we say minus type short, after we've already written out the image in the middle with minus O, we actually do nothing because it's already done writing that image by the time it gets there. So everything reads left to right. And the way it handles images is by use of a stack. So we put these things on the stack one after the other. Here in this command we have three images, A, B, and C. C3D reads them left to right and puts them on the stack. It's kind of like an inbox for images. And then when we come to this minus info command, or any command, it will take images off the top of the stack and optionally put some results back. And that's might seem like a sort of odd way of doing things, but as we'll see as we go through it, is pretty flexible and allows you to do quite complex operations. So this minus info command there will just go to C, because that's on top of the stack, and print some information about it. So here's a more realistic example of masking a head image with the stack illustration. So we first take the head. That is pushed onto the stack. When I say something's pushed onto the stack, that means it goes on top of all the other images that are already there. So head goes there, it's by itself. The mask is pushed on top of it. Then we come to the multiply command. So each command in C3D knows how many images it needs, and it will just go to the top of the stack and take as many as it needs. Multiply needs 2 images. It's called a binary command for that reason. And so it will take those 2, head and mask. It'll do the multiplication, and it will compute a result. The result gets pushed back onto the stack. So then when we come to the last part, which is -O, which means write the file output, it takes the result off the top of the stack and writes it at disk as brain.nii.gz. Now you may have noticed this multiplication's slightly strange in that it comes after the terms it multiplies. So we normally write math in infix where we say A times B, but then when you see the multiplication symbol, you have to look to the right. You have to look ahead to see what's going to come next and what's going to be multiplied by. In C3D, and to make the stack work, we put the images there first, and then we do the operation. So it seems like sort of strange Yoda speak, but it is the way that it makes the stack algorithm work and allows you to not worry about complicated expressions. You just order things so that the math gets done in the right order. So a little more complicated example, say we wanted to compute this expression, we wanted some result that is the product of image 2 plus image 3 and image 1. We would write that in C3D without parentheses and without worrying about operator precedence. We put the things on the stack and do them in the postfix order, and that way we don't ever have to use parentheses or anything like that. And everything just flows left to right. Okay, so because we have the stack and we have the results of things that we do still in memory, we can combine multiple operations. So in this example, we have things written as 2 different operations. I'm afraid the bottom one's cut off. So in the first command, we take the segmentation image, which is a 3-label image with CSF, gray matter, and white matter. We threshold out the label 2, which is the gray matter, and we write it out as a mask image. Then we read in our T1 head MRI. We then load the mask that we just made, multiply the 2, and output the result. So we could do those as 2 separate commands. But we can also do both of those things in one go, and that saves us writing an intermediate image to disk, which saves us disk space and saves us time. And if you have to do 1,000 images, it can save a fair amount of time. So let's load the T1 and then the segmentation. And then we'll do the threshold. Now, threshold, unlike multiply, takes only 1 image and then a bunch of parameters telling you what labels and thresholds to apply. So thresh pops something off the top of the stack, and it's up to us to make sure that's seg, i.e. what we want. Threshold it, result goes back on the stack. This is all still in memory, nothing's been written to disk. Then we call multiply the T1 image by that result. The result of the multiplication goes back on the stack, and then we write out the result, the final result, which is what we want. So we can combine sort of unlimited numbers of operations this way, and do that all in memory, which is much more efficient. Okay, so just to give you a go at actually using it, let's do exercise 9A, and we'll take about 10 minutes for that. All right, so just a couple of common errors that can happen with C3D. So we load these 3 images, call add, that takes 2 operations, put 1 back. Call add again, that takes 2 images, puts 1 back. Then we call add a 3rd time. By mistake, we've added an extra addition there. And then you'll see this error message, binary operations require 2 images on the stack. So if you don't have enough images there, it will tell you that. The opposite error will not tell you anything, so that's kind of why I'm bringing this up. So if we actually forget to make one of the additions there, we'll write something out with the -O command, but it's not actually what we want. So C3D doesn't check and doesn't, in general, know if you care about, things below it, the top of the stack. So if you leave things left over at the end, it will not complain. So just be careful of that. You won't see an error message. All right. So in that exercise, there were different spatial units, which we'll talk about, and also intensity units, and different ways we can specify those in C3D in order to manipulate images in the way we like. So there's different ways we can specify image intensity, with absolute values, with percentages, or a mixture of both. So the -clip command basically says, set everything below some minimum to the minimum and everything above some maximum to the maximum. So in the top row, the clip says everything in the image will then be between 0 and 1,000. And that's just in absolute values. We can also specify percentages, which are based on quantiles in the image. So it's based on the image histogram. So we can say clip between 1 and 99%, or we can mix and match both. So there's different percent intensity options. So that means we can change what a percentage means so the default is -PCMQ. You don't have to type that because that's the default. That means quantile. So it just means bin the image into a histogram and compute the quantiles and then apply the subsequent commands accordingly. So often this is not what we want to do because a large percentage of most or many images is 0. It's background. So if you've got a brain in a larger image, a lot of the voxels will be 0. So we can actually change that to ignore the background value with this -PCM FQ or foreground quantile. So now we're clipping between 5 and 95%, or the 5th and 95th percentiles of the non-zero or the non-background voxels. And then the other way we can do things is with range. Now range is really only useful where you kind of know the range and there's no outliers, because unlike quantiles, it's pretty sensitive to outliers. But you can actually say it, so you can do -PCMR and then the 5 and 99% at the bottom there will be interpreted as just being the raw range without regard to the quantiles. So there's different ways we can specify intensity. We'll go straight on to exercise 9b, where we'll just look at a couple of different ways of applying that to the same image. And this should only take about 5 minutes or so. Okay, so that's intensity units. Spatial units can be specified in 3D, either as millimeters or voxels. So in the example on the top here, we are smoothing with a kernel of 1 by 1 by 2 millimeters. And then we saw in the first exercise where we resampled the image, we specified in 3D, 1.5 millimeters. As shorthand, if you want to do something isotropic, you can say, like in the bottom example, 2 voxels. Okay, there's a few things for working with labels that are of interest. There's actually a lot more than we'll go through here, but one you can do, it's quite easy, is the -replace command. So here we just replace everything that's label 8 with 0, and that's just a little faster than messing around with thresholding and multiplying the results. There's other things for dealing with labels, such as shift and lstat, that we'll look at some of those. And then there's a few commands that I just wanted to show you that will let you manipulate the stack kind of freeform if you feel like it. So the dupe command just copies what's on top of the stack, and that can be useful if you want to do a bunch of things to the same image and you need a few copies of the original. Pop if you want to get rid of something that doesn't need to be there. And then there's the as. So as is pretty useful because you can actually label an image for later and save it for later use. So if we do this command, we do C3D T1 and then do -as head, that takes that T1 image, labels it head, and keeps it in a named images pile, where later on we can refer to it by pushing it back on the stack. So just running through this, we do T1 as head, then we load the mask, then we multiply, so we have the result of that multiplication now on the stack, and we can push head and then put that image that we'd saved back on the stack. So just a quick table summary. There's as for naming things, there's pop, push, put thing on the stack, take them away, duplicate, pop as, which is just a shortcut for naming something and then tossing it off the stack. And then finally, in probably the most dangerous command is the insert, where you can actually put things at arbitrary positions. But I tend not to use that very much because it's easy to confuse myself. Okay, so a little more on labels and segmentation. Often we want to know things about some grayscale image within a labeled region, and that can be, the whole brain or something more specific. So in this example here, we would load T1 and a T1 segmentation, which is this 3-tissue image. And then we do minus LStat, and that gives us some basic information about each label. So the mean standard deviation in the T1 image, and also the volume of the and the extent of the label itself. Sometimes we want to just look at labels directly, and we can do that with the minus overlap command. So here we load 2 segmentations that are, again, 3-tissue segmentations, labeled 1, 2, and 3. One is from a subject, one is from a template. We can then do minus overlap 3 and get the statistics for label 3, including the dice similarity and other things that we might be interested in. And then for loops let us automate things that we might want to do to a bunch of images without having to type it all out longhand. So here we load these 3 images on the stack, and we then go into this for loop where we want to smooth each image. So what happens then, when you encounter a for loop, C3D will go through the stack. It will take every image off the stack in order and apply some operation, and then put the result back in the place of the original. So what will happen here is it will take the first image, it will compute the smooth result, and at the end of whatever you do in that loop, and it's really up to you. You can do a lot of commands or just one thing. Just at the end, you just have to have one image on that sort of special loop stack, which then gets put back in place where the original image came from. So this continues for all the other images that were originally on the stack. We compute the second result until we end up with a one-to-one replacement. So those 3 images we put there before the for each are now replaced with the result of doing the for operation on all of them. And then if we want to output them all in one batch, we can use this minus -00 command. And this will write them out according to this file name specification. And the %d here means just number them one after the other. So one thing that is quite useful to use with for loops is the split and merge. So if you've got a label image, say T1 seg, we've seen before, has the 3 labels, but it could contain 100 labels. With split, we'll split them into binary probability images. So it will remember which label corresponded to which label in the original image. So they don't have to be sequential. They could be arbitrary labels. Split will remember which label intensity applies to which probability image. After split, you've got a probability image for every label that was in the original label set. You can then do anything on them. You can smooth them or whatever inside your for loop. Then at the end, you can merge, which is a kind of majority voting based on the processed images. So we put label 1, 2, and 3 on the stack after split. We do some for each, and then merge, and then we'll have a new set of labels, and it will remember which probability goes to which label and combine them sensibly. So that's split and merge and for each is a pretty powerful way to deal with a single image that can contain a lot of different labels. Okay, so let's go on to exercise 9C, which is the last exercise, and then we're about done. Alrighty, so just to quickly summarize, since we're about to run out of time, C3D has a bunch of features in different domains of image processing, and we've only sort of looked at a couple of them. It does manual and automatic segmentation, so there are commands to do the automated level set segmentation, as well as you can do manual segmentation. Minus staple is a way for synthesizing different segmentations. There is the basics of grayscale image math. You can do image calculator stuff. There's a ton of label editing. There's statistics, regression, registration and reslicing we didn't get into. You can apply warps to an image. You can reslice it to a different orientation, change its dimensions. And then there's visualization stuff, so you can create overlays and color maps and tile you can create 2D slices and output different parts of the image. So there's a lot of different stuff. It's all documented on the C3D website, and I would recommend going there and just even to look at some of the things that we've used to understand more about how those commands work, like minus thresh, and what their arguments mean. So just to sum up then, C3D gives us an interface to many ITK image processing filters. And these are pretty good, well-validated ITKs. They're a pretty nice toolkit, and C3D gives you a usable interface to a lot of it that you would otherwise might need to program C++ to get at. It handles both floating point and label images, so it's a companion to SNAP, but can also just do general purpose stuff on grayscale images. You can set up complex expressions using the stack. So once you kind of get the hang of the notation and the way the stack works, you can do quite complicated tasks in memory and quite efficiently. And then there's a GUI that we've used today, but you can also call it from command line scripts in an automated environment, and that way you can apply these operations to large sets of images. So yeah, and again, I would say see the website. There's a lot more background than what we've gone over here.